So, based on the notes from Friday, here's our warm-up. The one thing that's missing from number 1, focus, is that these are angle bisectors. Now, let's see, who remembers from Friday? When you have 3 angle bisectors, what does that make? What kind of center is that? No, that was Thursday, centroid. This is the new one from Friday. It's a something center. Check it out. Angle bisectors make a what center? In center. Okay. Well, we did, it was notes from Friday. So here we go. So this point right here is the in center. Now, yeah, let's put the word in center here somewhere. Now, I'm going to start with the second one. Finding angle FED. Now, real quick. Angle bisector means it cuts it in half. So if this is 15, what's this right here? 15. Good. Does that make sense? If you know one half, you know the other half. And then you can find the whole thing. What's this whole angle right here?
30.
Good, 30. Now, the reason why I care about that is because if this is 30 degrees, this is 58 degrees, I could figure out this other third angle, right? And then I can figure out what FED is after that. So first of all, I got 30, I got 58, and I got missing angle. What do those 3 angles have to add up to in a triangle? 180. So let's add up the 2 I know. 30 and 58 add up to what? No, I'm saying 30 plus 58. 88, okay? And to figure out this missing angle, I'm going to subtract it from 180. So 180 minus 88, 92 degrees. So this angle right here, this big angle is 92 degrees. But look right here, check it out. I'm looking for FED. By the way, FED is actually only half of it, from F to E to D. Isn't that just half? Not multiply, but divide 92, the whole thing, divided by 2. 92 divided by 2 is 48 degrees, not 48. Close. What? 46 degrees. Each of these is 46. So 46 degrees. Now, real quick, the reason why we're doing so much on this warm-up is because, remember that packet I gave you Thursday? If you need it, it's in the blue bin. But page 2 and page 3 you have to do those pages as well based on the notes from Friday. And it's just like this. So when you get to page 2, it's just like this. Different numbers. Okay? Okay, here's the other thing you got to know. Okay. It asks us to find, oh wait, hold on. I put that in the wrong spot. 46 degrees goes here. Now, up here, they're looking for the segment from F to CD. So from here, straight over here. Now, I'm going to show you the notes from Friday. What did we learn about an in-center? The in-center is equidistance from the sides. So see the segments here in blue? They're all the same when they go from the in-center to each side. So if you know it's equal distance to each side, well, let's see if we have another one to each side. So from here to here is what? 38, right? So that means from here to here is going to be 38. If you didn't, that would be bad, but you will. So, yeah, especially on the assignment, it's just a bunch of the same thing. Like I'll give you one centered to the edge, and for an in-center, you just got to know it's the same to the other edges. So technically, over to here too would be 38. Okay. First blank. Okay. So again, what do we know about an in-center? It's equal distance to each side. Cool. Second thing. Now, there's even more stuff over here. This was the second notes you took on Friday. Is everyone looking up here? Okay, we learned about mid-segments, okay, with the little Legend of Zelda reference there, with this Triforce. You know, sometimes I joke too much and I try to force one in. Try to force. Thank you. All right. Well, anyways, what do we know about this relationship? Okay, let me do that one in black. All right. So check it out. This is 18, right? This, and by the way, what do you call it when you connect two midpoints? Mid-segment. A segment between two midpoints is a mid-segment. Okay. So what do I know about the relationship between the mid-segment and the parallel side? Perfect. It's half, right? So if that's 18, then these two other halves are also 18. And then they add up to what? Not 180. 18 plus 18. Okay, 36. Now, let's see if we answer this. GJ. All right, so check it out. GJ, all the way across, 18 plus 18, we just said is 36. Now, let's do RQ. Again, this is just like your third assignment in that packet, just different numbers, okay? So RQ is not 53. Does everyone see that's 53 degrees? So that's an angle. But check it out. HG, this whole side is what? So how do I figure out QR or RQ? Not subtract, but divide by 2. It's half, right? No, half of, yeah, 53 is a degree. Don't worry about that yet. So 13 is every single one of these segments, okay? 13, 13, and 13. So, hey. RJ is what? It's already labeled. No. RJ. 18. Okay. So you get the idea. If you know one little piece, you can figure out the other pieces. J's way out there, yeah. Now, let's talk about the angles. There's one angle that's given. Does everyone see it right here? 53 degrees is this acute angle. Okay? Now, that's going to help you answer these last 3 angle questions. But check it out. If that's 53, alternate interior angles, this is also 53. Corresponding angles, this is also 53. Corresponding angles. All these purple or pink ones are all 53 degrees. Okay? So, first question, PQR. PQR is what? Well, no, these are congruent. So this is also going to be 53 degrees. Sorry if I'm in the way. HGJ, down here, HGJ, corresponding, it is 53, again, because they're congruent. But this last one, check it out. GPQ is an obtuse angle next to 53. Right, so it's a linear pair, it's supplementary, it adds up to how many degrees? Straight line is how many degrees? 180, right? Straight line is 180, right? So if this is 53, to figure out the other one, I subtract it from 180. So what's 180 minus 53? A number, 127 degrees, okay? Now, I know that was a lot. Okay, I'm going to pass out the notes for today. I'm going to warn you now, this can be kind of confusing. It's brand new, so everyone needs to be focused. So when we get started, we're not doing headphones or phones, okay? Let's get this over with. Let me pass this out. Okay, let's get started here. All right, so today, actually let's recap. Thursday, if you look up here, we talked about this center. What was this one called? Centroid. Y'all remember that? Centroid. Looking over here. Okay. Centroid is the one that balances, and it's made by medians. Okay. Then, so this is called an orthocenter. So Friday we learned about an in-center. Friday we learned about in-center based on angled bisectors. Today we're doing altitudes that make an orthocenter. Now, what does altitude make you think of? Okay, it does make you think of height. If you're in outer space, that's crazy high altitude. Also, being in an airplane, climbing a mountain, whatever. Altitude is the height of a triangle. Okay, so if you have three altitudes, okay, which are what? Perpendicular from a vertex, they're going to all cross at a point of concurrency. Y'all remember that's where three lines cross? And that point of concurrency is called a orthocenter, please. Okay? So it doesn't have to do with teeth, okay? Mrs. Marrero was saying orthos has to do with being, with straightness. So again, like a straight height. Say what? Yeah, I can. Did you hear what type on? Yes. I like that. Yes. That's what orthodontist straighten your teeth. Orthodontist straighten your teeth. That's what he just said too. Everyone's got the same good ideas. Great. That's because you're bringing meaning into the lesson. All right. So now, real quick, this is weird. Orthocenter can be on the outside. Let me say that again. The center of a triangle can be on the outside of a triangle. Isn't that weird? Look over here. Look over here. How does that make any sense if the center is outside? Right, so it's an orthocenter. It's a special kind. Let me show you how it works, okay? At the bottom, okay, we're going to not turn and talk, but we're going to do this together. We're going to sketch three different orthocenters, okay? Three altitudes. So remember, an altitude is from a vertex, and it makes a right angle. So sketch that. Vertex makes a right angle. Sketch that. And then vertex makes a right angle. Sketch that. Now, does everyone see that this orthocenter is inside the triangle? So again, what kind of triangle is this if all the angles are less than 90? Acute. And the orthocenter is inside the triangle. right there. I'm going to show you right now. Now, this next triangle has a big angle bigger than 90. What's that called? Obtuse. Now, if it's obtuse, this is going to get weird. So follow me. From a vertex, it's supposed to be perpendicular to BC. The only way to do that is if I extend the line straight down, makes a right angle. If you have an obtuse triangle, the altitude is outside. It's the only way it can make a right angle. You don't have to, but... Now, same thing with C, okay? I have to extend this line, make a right angle, make a little nicer than that. Oh my gosh. Sorry. It's a rough sketch. And then, last but not least, so to make a altitude, it's from a vertex, and it has to be perpendicular to the opposite side. So when it's obtuse, the only way it can be perpendicular is if the side extends. Like if you went inside the triangle, it wouldn't be perpendicular. It'd be like obtuse. Yes. So does everyone see that this orthocenter is outside? So for the middle one, yes, outside. Okay. Now, take a wild guess. What do you think about a right triangle? Where's that going to be? So that should be on the edge. Okay, so inside is acute, outside is obtuse. Check it out. The altitude has to be on the edge of a right triangle because it needs to make a right angle. It's on the edge because it makes a right angle. And then it goes through the vertex. So the orthocenter is actually not only on the edge, but it's on the vertex of the right triangle. Yeah, on the vertex of the right angle. It's okay until we flip it over. Now, it's okay. So, if you have that down, you can flip it over, and we're going to graph two of these. Okay, there's some specific steps that we're going to write down here in a second. So, as long as you got this down, we're going to flip it over. Just remember, orthocenter can be inside, outside, or on the edge. Ready? Everyone ready? Almost. Okay, moving it on now. Now, if you can, I would like for you to write these 4 steps down, okay? Because you need to know what steps we're doing to make these altitudes. Okay, so write this down. Step 1, plot the points and draw the triangle. So write that down. Write the steps. And then write step 2, find each slope. Write step 3, find the perpendicular slopes. And write step 4, graph perpendicular lines. So if you have those 4 written down, let's plot those points and label them. So negative 4, 2, J. Negative 2, 6 is K. 2, 2 is L. And I'd like for you to use your protractor to make straight lines. So everyone's plotting these points. Yeah, it should make a triangle. So everyone's doing JKL, and I'm not even JK.
So we're just kidding?
No. I don't have copies before we do them. I have copies after I do them. No. Yeah. I mean, whatever I write, then I print out. All right, so first step, we plotted them and we drew it. Second step, we need to find each slope. Now, stay with me as I do this, okay? Let's pick a side, and the side we're going to pick is JK. Listen, JK. So, slope of JK. Now, do y'all remember what slope is? Slope is what over what? Rise over run, okay? Now, for JK, all I got to do is count the rise and count the run. So y'all tell me, from J up to K, how much does it rise, how much does it run?
6/2.
Not 6. 4 over 2. 4 over 2. Okay. So, but we want to reduce that. What does 4 over 2 reduce to?
2 over 1.
2 over 1. Now, so that's step 1. Get the slope. Now, step 2. So, step 2 is to write the perpendicular slope. Now, what two changes happen to a slope when it's perpendicular? Flip is part of it, and the sign changes, right? So this was a positive, it becomes negative, and then 2 over 1 flips to 1 over 2. So again, this is a reminder, because we've done this before. 2 over 1 is perpendicular, is negative 1 over 2. Now, once you find that perpendicular slope, you need to use it at a vertex, and we're using it at the third vertex. So JK is right here. What's the other vertex over here? L. So we just found the perpendicular of JK. We're going to use it at L. Bless you. True. Now, here's what we're going to do. We're going to use this new perpendicular slope at L. So everybody, put your pencil at L, put a point there. And what you're going to do is use that new slope, negative 1 over 2. Is negative up or down? Down 1, and always to the right 2. Now, if I go down 1, right 2, that's outside the triangle, right? Down 1, right 2. Down 1, right 2. We're going to draw an altitude. That's what we're doing right now. But check it out. Negative 1 over 2 goes down and to the right. We could also go the other direction. What's the opposite of down and right? Up and to the left. So we're going to go up 1, left 2, up 1, left 2. Use your protractor to make a nice straight line using those points, right? So, and that is perpendicular. We just did the altitude starting at L because it's perpendicular to JK. Then we're going to do the same thing for the other two segments. So let's do the slope of KL. Now KL, what's happening each time? It's going which way? Down 1, right 1. Down 1, right 1. Down 1, right 1. So what would the slope be? Instead of down, what do I put? No, hold on. What does down mean? What? Negative 1. Right 1 is a positive, yeah. So down 1, right 1 is negative 1 over 1. Okay? That's my original slope of KL. Well, now, the perpendicular, now we're going to do the changes. So negative becomes positive, and then 1 over 1 flips to be the same thing, right? So it's just positive 1 over 1. So again, the negative became a positive, and the 1 over 1 flips to become 1 over 1 still, okay? No, they both flip, but they're both the same number, so it's 1 over 1. So real quick, what's the third point? KL, the other point is J. So we're going to use 1 over 1 at J. Okay, so put a point at J. You should do this. And then from J, we're going up 1 over 1. That means up 1, right 1, up 1, right 1. So put a point, put a point, put a point, up and to the right, up and to the right. And then you can draw that line. Whoops, sorry. Now, let me give you a little hint. Once you do 2 of these, where they cross, that's going to be, well, what's it called? What's that point called, though? Not the centroid. Okay, but what's the name of this point? Orthocenter. It's okay. So technically, you already know where it is, okay? The third line should go through that same point. So I'm going to just do that real quick. Oops. Technically, you would have the right answer, so I wouldn't be mad. But just I'm on the notes, I'm being thorough here. So the slope of JL. Now, we should know this one real quick. JL is horizontal. What's the slope of a horizontal line? What's the slope of a horizontal line? 0, right? Because it doesn't rise, and it just runs. So the slope of JL is 0. Now, some people get confused, and they think, oh, it's undefined. So let me tell you the difference. Well, because vertical and horizontal, one's 0, one's undefined. So here's how you know. Can you stand on a horizontal line? Yeah, 0 effort, 0. Can you stand on a vertical line? Unless you're Spider-Man? No. So that's undefined. If you cannot stand, it's undefined. If you can stand, that's 0. Okay? So horizontal line is 0. What's the perpendicular slope going to be? Not 0. We just said the perpendicular for horizontal is vertical, and vertical, you cannot stand on it. It's undefined. Now I'm going to put UND for undefined at what point? Sorry, what letter? JL, the third one is the letter. Okay, so at K. So that means we're going to make a vertical line at K. With me? So from K, going straight down. Hey, does it go through there? Yeah. Makes a right angle. So this point right here is my orthocenter, like we just said. How would you find that point without doing the altitude? The mid. Okay, well, real quick, what's this? What are the coordinates of this? That green dot over there, the circumcenter. Sorry, the orthocenter is -2, 4. So again, find the orthocenter. We did that. Okay, now, these are the steps to do it. Okay. Oh my gosh. Maybe. Okay, so number 2, let's plot these points. 2, -2, put a point there. That is K. 4, 6, put a point there, that's L. 8, -2, that's M. Okay. And then connect them. So we plot these points connect them, connect them, connect them. Okay. Now, we're going to find the slope of all three, right? So slope, let's pick KL. Who knows the slope of KL? What's the rise over run? The slope of KL. You know what? This is supposed to be up here. Oh my gosh. Okay, sorry, what was it? 8 over 2? Okay, which reduces to 4 over. Now what's perpendicular to positive 4 over 1? Instead of positive, we put negative, and then flip it. Negative 1 over 4 at, not KL, what's the third letter? M. Yeah, it can't be the 2 that you used. So I'm going to use negative 1/4 at M. Now check this out. Negative 1/4 means down 1, right 4. But if I do that, I'm off the grid. So what's the opposite of down and right? Up and left. Up 1, left 4. 1, 2, 3. Okay, that's my altitude. Let's do LM. So the slope of LM. Now, does everyone see it? LM goes down to the right. Down what? Now, it looks like it goes down 2, right 1, down 2, right 1, down 2, right 1. Hey, so what's down 2, right 1? What does that mean? Negative 2 over 1. What's perpendicular to negative 2 over 1? 1 over 2, right? The negative becomes positive, and you flip it at, and instead of LM, it's going to be K. So from K, we're going to rise 1, run 2. Okay? So from K, up 1, right 2. There's that point. Up 1. Orthocenter, yeah. Now you can already see where they're going to cross, right? But let's finish it off real quick. The slope of KM is horizontal. What's the horizontal slope again? Is that 0 or undefined if it's horizontal? 0. So perpendicular is going to be undefined, a vertical line at point L. So at L, make a vertical line, and guess what? It does go through that point. What is that point called? Or what's that coordinates of that point? With the ortho. 4, negative 1. X before Y. It's all good? Okay. So you get the idea. Okay. Make sure you show some work when you do that. You get the idea on how to do it. So this was our 1, 2, 3, 4th notes out of that packet. So you should be able to do the 4th page in that packet. Tomorrow we'll do the 5th one. Then we'll have 2 days to finish it up. Then we'll have a quiz on Thursday. Unless we need an extra day, we'll push it to Friday. I don't think anyone wants to do a quiz on the Friday before the break, but if we need it, we will, okay? But yeah, Thanksgiving is next week, so. All right, so right now you have time to finish writing down these notes and start working on that packet for day 4.